So now finally we've moved on to new coordinate geometry, so stuff that wasn't on the junior cert that we're just learning now in the leaving cert. So the first one of these is getting the area of a triangle, or specifically it's the area of a triangle with one corner, or vertex as it's called, technically, but you could say corner if you want, on the origin. So see this triangle here, there's the three corners and one of them is on the origin, so 0, 0. Then you can use this formula here, so A is the area is equal to half by the modulus. So the modulus means that it's always going to be a positive number. Go through that later. So the modulus of x1 multiplied by y2 minus x2 multiplied by y1, where these are x1 and y1, these are x2 and y2. Yeah. And the modulus means it's always going to be a positive value, because sometimes if you put those numbers in, you're going to get a minus number. But obviously you can't have a minus area, so basically just stick the modulus on so you can get a positive answer all the time. So the easiest way is by looking at a quick example. The easiest example actually would be, okay, what I'll do is I'll say that this point here is 3, 5, and that this point here is 7, 1. Now I know it's practically 6, 1, but imagine it's stretched out a little further. Okay, I'm going to do this example here. So that's x1, that's y1, this is x2, and this is y2. And then we're going to have our formula here. So A is equal to, again, just half by x1 y2 minus x2 y1. And just be careful you don't get mixed up. It's easy to get confused. The formula is in the tables book anyway, so you have it there. So A is equal to half multiplied by x1 is going to be 3. Y2 is going to be 1. Minus x2 is going to be 7. And y1 is going to be 5. So that means A is equal to half of, that should be modulus, 3 minus 35. A is equal to half the modulus of minus 32, okay, which is just the same thing as A is equal to half times plus 32. So that's what the modulus does, then it's just in brackets. And our final answer then, A is going to be equal to 16 units squared. Okay. Yeah, so that's just a basic example of where you can use that formula to get the area of a triangle. So if you want, you can work out the angle here, or you can work out the length and the base and the perpendicular height and stuff. So that's another way of doing it, but it's longer. So this is a quick way if one of the corners is on the origin. Yeah, but there's also a way, so they can ask some questions where the corner won't always be on the origin, but there's a way of getting around this, so you can use this formula here, and I'll go through that now. I'll just scroll down a little bit. So yeah, so that's all just if it's one corner is already on the origin. So now we're going to look at if it's not on the origin. So here's an example like that here. Find the area of the triangle with vertices at -3, 4, 6, 10 and 4, 2. So first thing, vertices is just the plural of vertex, and again vertex is just another word for corner. So the question could be, I just want to put that in just because that's probably what they're going to say during the exam, but you could say the corners at those points, right? Yeah, and we want to find the area of this. So we can't use this formula because one of the points isn't at the origin. So we're going to have to fix that by doing a thing called translation, or just moving it, okay? So translation, so I know that kind of means like changing one language into another, but it also means moving something, okay? So translation can mean moving. So we're going to translate this point here. We're going to move it from -3 to 4, or so -3, 4 to 0, 0, right? So if we move that point there, then this point will go down the same amount, and this point will go down the same amount as well. So now we can draw a new triangle like this. Should be the exact same triangle, it's just moved down a little bit, okay? So just if they use translation in the exam, just know that that just means moves, alright? So how are we going to find the new points now is the question. So the way you're going to do it is, we'll say yellow. I'm going to scroll down a tiny bit more. So we know that -3, 4 went to 0, 0. So that means you added 3 to the x and you -4 from the y. So I'll just say x and y, yeah? So that means the rest of them, the exact same thing is going to happen. So for this here, this point here, 610, we're going to plus 3 to the x because it goes from minus 3 to 0. So that means it's plus 3 of a difference. So it's going to be 9. And then minus 4 from the y. So it goes from 4 to 0. That means it's going to go from 10 to 6. Make sense? And we do the same for the last point then. So the last point was 4, 2. If you plus 3 here, it's going to go to 7. And minus 4, it's going to go to minus 2. So now these are our new points here. So I'm going to call this one here x1 and this one here y1. This one here x2 and this one here y2. And now we can find our area. So A is equal to half by, just make sure I don't get this mixed up, it's x1 y2 minus x2 y1. Just again, be careful, it's really easy to get confused there. So that means A is equal to half by, so x1 is 9, y2 is minus 2, minus x2 is 7, and y1 is 6. A is equal to half, so this is going to be minus 18, and this is going to be minus 42. I'm just going to draw a line in here. So A is equal to half of the modulus of a minus 60. So that means A is equal to half by plus 60, we'll say. So modulus, remember, changes it to positive. So A is equal to 30 units squared. Yeah, I'll just say SQ for squared. And that is our answer. So that's the answer of this blue triangle here. So that's the amount of area in the blue triangle. But because we moved this red triangle the same amount, each point moved by the exact same amount, this also has area 30. They have the exact same area. So that's our answer for getting the area of this triangle here. Yeah, so we got the triangle of the blue one, but it's the exact same as the triangle of the red one. We just moved the red one down to turn into the blue one. So hopefully that makes sense. They're the two kind of basic questions you're going to get anyway on calculating the area of a triangle using this formula. We're going to look at one harder example in the next video. So hope you enjoyed this one. Like and subscribe, and we'll see you in the next video on more areas of triangles.